get into a discussion on an often misunderstood part of the Cimatron mold design process, the parting assembly and the layout part. We're going to explore the purpose of the layout part and the options it provides to easily manage the part locations. And then we'll also take a look at the work coordinate system and a few other functions too. Let's start by saying that a mold design is really just an assembly of parts. There are some sub-assemblies to organize the parts in, like the fixed side, movable side, but all of those assemblies share a common 0 point, which is going to be the dead center of the mold. And the Cimatron philosophy is that this is the point that does not move. All of the mold-based parts are going to center up on that. So, as the mold base does not move, you need a way to arrange and adjust the position of the part, or parts, to be molded relative to mold center. And that is the basic purpose of the layout part. Cimatron provides a few default layout parts in inch and in metric units. These have basic functionality and they suit many circumstances, but it's also incredibly easy and useful to just create your own layout part for a job. By creating your own layout, you can position parts in any way you need to and have the full control to edit those positions later on. So let's jump into the software and take a look at working with layout parts. Most users probably start a new job using the Mold Design Wizard. This sets up the mold assembly structure and it can make a job folder. But if you notice, even here at this first step, you're already being asked to specify a layout for the job. Now, if you know how many parts the mold will be making, and you're familiar with the default layout parts, go ahead and select one. But if that information is up in the air, you're actually better off checking the box to create your own layout part. That's something we're going to show in the second example. So we see a new assembly being created and the wizard is creating the sub-assemblies there in the tree. And the reason that the mold wizard required us to select a layout part is because it's actually the only part it adds into the empty design assembly. That and these assemblies are all you get. The parting subassembly is left as the active assembly. So let's talk about that for a minute. Unlike the other assemblies that hold mold components, the parting assembly is only designed to hold the parts to be molded. Parting is for doing quick split work. Parting is for designing shutoff surfaces and checking engineering changes. Sometimes these activities take a lot of thought, so you end up spending a good deal of time working in the parting assembly. But the point is, it's definitely a special assembly for very specific tasks. And of course, as you hopefully know, there is no set order to mold design in Cimatron. If the job is quoted and you know the size of the mold base that will be used, you can leave the parting assembly and add all of those mold parts right now. Now they will, as mentioned, all come in on the main mold center UCS. We're going to add parts first. This first example part is read in from a step file. Now the only reason I opened it up on its own is because I want to point out in the part where the only UCS it has is. Because the part coordinate system, this UCS, has a bearing on what we talk about next. Let's close that. Because to add parts into the parting assembly, you always use the load work function. This function copies the part into a work file where shrink and other molding features can be added on top of the original customer data. And then it has you position the parts in a layout. Now, where the layout spots are at first doesn't really matter. The whole point of the layout is adjustability. You just need to get them on the screen, see how they look, and then adjust them from there. Now, something to note right away, and it refers to the coordinate systems I was just talking about. When you drop a part on a layout point, you naturally expect to see the part right there on the layout point. not 6 feet off to the right. But that is what would happen if we were to use the UCS in the part as its anchor point. In this example, the UCS was nowhere near the part, and that's really a common scenario, especially in automotive work. So we do something right now to provide a better anchor point in the work part. We create a work coordinate system, which we can edit now to see how it's made. So Works UCS is nothing more than a coordinate system that we're making at the dead center of the part's bounding box. And the Works CS is made in the part, and its one and only purpose is to serve as the anchor point to the layout. That's all it does. But you have complete control over where on the part it's made. It doesn't have to be at the part dead center, of course. You can pick other points, or you can use the optional steps to tilt or rotate this UCS, which in turn tilts or rotates the part on the mold layout. For now though, I'm just going to prove the Work CS at part center and get back to talking about the layout. Activating the layout part shows its feature tree, and generally speaking they only have 2 features inside them, a sketch of points and then a special layout UCS. It's the sketch that provides the adjustability. By editing the sketch, the layout UCS will move. In this particular layout part, however, we see that the dimensions are linked to the setup table, and that's pretty common in the default layout parts. So in these you don't edit the sketch directly, you have to edit them from the setup screen. Setup, of course, just provides a central place to change the dimensions without having to know where the sketch is that you want to edit. The distance can be set to anything, but the angle field is tied to a drop-down list of common angles. So those new numbers then go into the sketch, which moves the layout UCS, which has to move the parts. And actually, that's not all that moves with the layout. If you had the load work function, add parting surface parts, those two are going to be tied to the same layout points, so those two will move and rotate when the parts do, which is pretty important. So the sketch points are what control the location of the layout points in X and Y, but the layout UCS itself has options in it too. And if you edit the feature, you're going to see that there are 4 adjustments possible. Moving the entire layout in Z, or adding a rotation along X, Y, or Z. The rotation here is not the same as rotating the sketch like we just did. The sketch angle rotated the whole layout in relation to mold center. A rotation angle here just turns each part around its particular layout point, which is good to have, but a common question we get is, how do you control each part individually? What isn't very apparent when you're editing the layout UCS feature is that the screen boxes are global, so those work on all of the layout UCS together. To work on only one location, you have to know to click that particular layout UCS. So that reveals the same controls, but only for this one spot, which means I can turn this one part while not turning the other one. As far as altering the Z height, that would raise or lower the layout point relative to mold center. Let's take a look at that. Because one position now has a local control, I'll actually have to add that in twice. So having to adjust the Z value is really a common thing. In fact, it's needed all the time practically, because the dead center of the part in Z is rarely ever a really relevant plane. But changing the work CS location can also change the part Z relative to mold center. So, if there are 2 ways to make the same adjustment, which is the better one to use? Do you move the layout points or do you move the work CS? And that is really the most common question we get about this whole process. The only answer is that both options can do the job. But adjusting the Z height in the layout can only be done by typing a number. Adjusting the Z height by the WorkCS allows selecting a point, which in my mind is a better choice because you're actually touching the part geometry. But really, the way the whole layout points and WorkCS work together, editing the layout is the natural choice for adjusting the part XY location in the mold, as well as individual rotation. But for adjustment in Z, or for changing the draw direction, the tip of the part, this is better done by editing the WorkCS. So that's kind of what I would recommend as the basic rule of laying out parts. Let's make a couple more adjustments here. In this case, I'm getting things organized about how I want, but I do need room for a runner system. Now that's an XY adjustment, so I'm going to use the layout, which we know is driven by setup. And then I do want to adjust the Z because this part has kind of a main flat on the part. That's going to be mold parting line. So I want it on the mold base parting line. For that, I'm going to edit the WorkCS, which means I have to activate the part. Now, I did say that when editing the WorkCS, you could select a point. But unless it's one of these blue points on the screen, on the bounding box, it's a point you're going to have to make yourself. But remember, feature order is important in the work part. Be sure that this new point that you make, if you haven't prepped it before this, resides higher up in the feature tree than the WorkCS, or else you won't see it when editing the WorkCS. But implicit points are okay too. So what I'm going to do for our example is just filter to a circle center on the plane that I want. And that's going to put the WorkCS there. Now my main parting line and my mold base parting line are dead even, and that's what I wanted. Now, as you probably noticed, because I did pick the circle center, the part moved a little in X too. And in this case, I don't mind, but I could always go back to the layout and move them again if I needed to. Now, through all of this, the WorkCS continues to sit right on top of the layout point. That's its only job. That's what it does. Now let's create another project. And again, we have to choose a layout part. Even if the job is just a single cavity, the layout part still has its purpose. It still gives you the adjustability to move that one part around relative to mold center. This time though, I don't want to use a system layout part. I'm just going to create my own. When creating a new layout, the system leaves you in the new empty layout part that it makes for you. And I know that the only two features I really need to make are a sketch and some UCS. So the sketch is like any other type of sketch. You can use symmetry lines if you want to, or you can make some points and align them, or choose not to do that. It all really depends on what kind of relationships you want between the part locations. I'm going to make a layout for 4 parts, and I want dimension control to be from mold center, but I do want some symmetry too. So in my case, I'm going to use relations to link the dimensions. If I want to try that out, I can put in a few different dimensions here. So that gives me the adjustable points that I want. And I could link these to setup, of course. That's an easy step if I desire. The layout UCS function is found in the Layout Tools menu. And you want to be sure to use this function, not just any UCS tool, because only Layout UCS is going to give you the right options for rotation and Z height that we saw earlier. The Layout UCS gets a number in the name, but you know you can name these anything you want to, so cavity 1, cavity 2, sometimes I like to do that. And if we look in the tree, I'm done. This is all a layout part needs. We see a sketch and a layout feature. If you like this layout part and you think you're going to use it again, feel free to copy it over to the system layout folder because it's as good as any that came from Cimatron. Next step, of course, is to load the work part. And like before, we're going to drop the part on the layout points. Now, the tools in Cimatron were built to allow you to get parts into molding position in a mold project, even if you've never looked at the part before. Now, often that's not the case. Probably somebody has looked the part over and thought about the best draw direction, and perhaps even created a pull coordinate system, which would be nice, because even though the work CS gets made at the center of the part box, as we saw, the Z direction still just comes from the part UCS. And there's no guarantee that that is the right draw direction. So in this case, I'm going to assume that no one has prepped the part at all. And I know that the part tilt is definitely wrong per the mold center. So I have to figure that out on the fly while working on the layout. The optional steps in the WorkCS function are rotation or for delta values. And these are useful, but again, you have to type in the numbers. For now, it's better to just stay at step 2 of the WorkCS function and select something from the part that's going to orient it correctly. So if there was a better UCS in the part, I would select that now. But we also have the typical Cimatron vector arrow. And that vector is setting the Z positive direction. Now, I don't know for sure, but this part looks to me like X might be a better choice for draw direction. So that's what I'm going to try. We only need to work on one of these parts as they're all the same. And before I start using quick split and getting on with this design, I think I'm going to check the part orientation that I've guessed at using the direction analysis function. So you can check the part angles and view it that way, or switch over to the 2 opening style of analysis. And that looks more like what you're going to see when you do get to quick split in a minute. There's only 3 colors in this type of analysis. So what it's showing me is that the tilt is fairly close, but there are still some undercut areas that probably were designed to pull. And let's point out, we've added some buttons here recently. These are new options in direction analysis that can help you fix undercut problems, and they're all here under the Orientate Part button. So in here you can pick geometry to tilt the part and then have it update the WorkCS. Or you can even run a part analysis and have the system suggest to you what it thinks is the right tilt. And I think these are pretty cool options. But for today, I just want to stick with the focus of our webinar, which is the layout and the WorkCS. So we're going to do it a different way. We're just going to keep editing WorkCS until we get this right. WorkCS, of course, is a feature in the part, and you can edit it as often as you like. So I know that the vector I picked in X wasn't quite right, but of course the vector offers you all kinds of options, like normal to a face or some other reference geometry. And often on a part, there are some features, common part features that sort of imply the right draw direction. So I think I am going to set the vector arrow along this boss face, as that's likely a pretty good choice. Now if I go back into direction analysis, I'm seeing a much better result. So the boss direction was a pretty good choice to pull the part. Most of the backdraft issues are cleared up now, and the few that are left would need a little attention. So of course, all that picking the vector arrow really does, though, is it sets the Z direction of the WorkCS. It's still at the center of the bounding box. So to finish the part orientation, again, you have the same two choices. Should you adjust the WorkCS or should you adjust the layout? I don't like the current XY of the bounding box that we're at. And I'm going to fix that by adjusting the WorkCS, because it exists inside the part. But the position of the parts relative to one another, of course, is something I'm going to fix by changing the layout. If the parts are going to sit horizontally like this, I definitely need some more room between them, which means editing the layout sketch. That looks better. And I do think I'd like to turn two of the parts. That should make parting surfaces an easier shape to make. So that means editing the layout UCS. As far as the part Z height relative to the mold center, this part really doesn't have any obvious surface that should be the main parting line. So in this case, maybe the center of the part is actually not too bad of a spot. At least for now, it's fine. And if I do want to move it after the mold design gets farther along, well, I can easily do that. Adjusting the part layout is something you can do at any point in the design process. And that's where I'm going to stop on the topic today. Here are a few of the high points I want you to remember from this webinar. 1, the mold center of the assembly itself does not change. And that's why we have to adjust where the parts sit in the assembly. Also, it's really easy to make a layout part for any arrangement or number of cavities that you're going to have. Remember, you only need to make 2 features in it, so really easy. And adjustment of the parts can be done in 2 ways, by the WorkCS or the layout, because they sit on top of each other. But remember, only the WorkCS allows you to reference geometry directly in the part. So that's the one that you typically use if you want to change the draw direction of the part.